is the dots on the dice. So
It's a Hubble.
Sure, that too. So it's just like this term for the number of the little things.
Great.
So what I want to do is I want to analyze the results of what you guys just saw in your experiment. Okay? So I'm going to walk around the room, and what I want to do is I want to have you guys raise your hand. I'm going to call out each of the possible outcomes of the experiment. Now, what were or are the possible outcomes of the experiment you guys just ran?
1 to 6.
Exactly. 1, 2, 3, 4, 5, and 6. You are able to list them discreetly out. You're able to list them discreetly out. I like that. I call them X, and I call them the number of pips. I want to get us using a term right now. This column is a list of what are called random variables. I'm going to put that up here. A random variable. I'm usually going to call that X, just like I've been calling it all term. All term, we've been collecting data that are X values. They, even though they were data and not technically random variables, they were, to some extent, random variables. Let me explain why. What a random variable is it's a value collected that is, and here's the kicker, somehow dependent on chance. Rolling a die is a perfect example of one. Please, Riley, go.
What's the second word of the...
A value?
No, this...
Variable?
No.
Is?
No. The second line.
Collect.
Collected?
Okay. Collect.
Yeah.
These are simple words too.
It's like...
Looks like infinity.
Everyone's like you.
There's a value
you.
of corrected.
The period?
Thank you. Big up.
Oh, that looks fun.
Is it value collected? No.
Is a value collected. It's a value that you collect from an analysis. And that value has something to do with chance. Now, the reason I put somehow underlined, is sometimes it's more dependent on chance than others. For example, in class last time, I asked you guys to approximate my weight, right?
130.
And that's, I remember the 130. But the idea was you probably didn't just guess a number. You probably looked at me and said, okay, he's probably heavier than 70, but less than 500. So in your mind, there's some kind of a range you set up. And then you whittle it down, but once you got to that whittle, when you got to the last step, you probably didn't precisely figure out what my weight was. You took a stab, an educated guess, based on the data you had collected visually. That's somehow dependent on chance. You threw what you thought was an average of your interval and guessed at that middle. What you just did is a much more chance-driven event. You took a die and you rolled it, and you let it fall. Now, both the experiments of guessing my weight and rolling the die have a fixed number of outcomes, technically. For example, the least amount I could possibly weigh would be 0 pounds. I mean, mathematically and physically, 0 pounds. What's the most I could possibly weigh? Well, technically speaking, infinite pounds, but I'm sure there's been a heaviest person on record. We'll say it's 1,000 pounds just to make it ridiculous. Chances are, I'm somewhere between 0 and 1,000 pounds. When you, I'll just like, yes, I think you are. That's a good range. I'm 100% sure between 0 and 1,000 pounds. The dice you just rolled, when you throw a die, you don't know what you're going to get. But you know what you could get, right? You know you could get a 1, a 2, a 3, a 4, a 5, or 6. So some of it's dependent on chance, and some of it is a foregone conclusion. You know you're going to get between 1 and 6. You just don't know which you're going to get. Just like a roulette wheel. That roulette wheel spins in the casino, and you know it's going to be 1 to 36 or 0 or double 0. You just don't know where it's going to fall. Some people argue you do. I argue they're wrong. It's okay. We'll get back to that too. Called the gambler's ruin. But the fact of the matter is, it's somehow dependent on chance, and some of it is a foregone conclusion. Fair enough? Okay, let's collect our data. Enough jibber jabber. I want to collect the frequency column. I want to collect the frequency count. Raise your hand and show me with a number of fingers how many ones we got. How many ones did we get? Now, this is the hard part. I have to count these. 9.
My dad dude over there has 4.
Oh, you know what? Say that again. Keep those hands up. Keep those hands up. Say that again, whoever said that statement.
I said almost everybody got 2. Like
Look at
looking
that.
around.
Wow. Lots. I've never thought to micromanage the sum. I've only looked at the sum before. So we got the hands up. I see 3, 2, 2, 1, 3, 1, 1, 1, 1. A
4.
few 2s over here.
4.
What do you think those are? No, good, careful. Hey,
4.
don't forget the people without their hands up are zeros.
Oh.
Ah! So this brings up a very good point. On average, what should it be?
A number?
What number?
What?
1, 2.
Oh, this is a great little question, Riley or Alicia, whoever said it, or
Linda?
Andrea, or whoever, Linda. This is a really cool question. So the question was, the statement was, I see a lot of 2s. My response is, I see a lot of zeros. Keep those hands up. I didn't tell you to put those hands down.
You only see like 3 zeros.
But I'm drawn to them.
Oh, 4.
Don't forget Lily behind you, biased sampler. I love this. What a great thing. Thank you. In 20 years of doing this, I've never thought about doing this, analyzing the individual results. Thank you. Interesting. What should it be on average? If we averaged out your guys' figures, including the zeros, how many would everybody have?
1.5.
Think 1.5, 2, 1.5. Keep that number in the back of your head, okay? We'll come back. I want to revisit that one. Okay, now I'll count. Hands up. 7, 9, 11, 13, 15, 18, 25, 30, 35, 41, 42, 43, 44. Thank you. I'll kill the camera for this part. We can collect the data without having the whole thing recorded.